Hi Year 4, I hope you're all doing really well and having a good week so far, and I hope you're getting on with decimals and tenths okay. Now, today, our calculation starter is going to be number sequencing. So you've got some sequences of numbers in front of you. However, there are some spaces in the sequences. So I want you to see if using the numbers in front of you, you can fill in the missing numbers from the following sequence. Okay, so what do you maybe notice about the two numbers that are there, and see if that can help you fill in the rest of the sequence. So I'll show you how I'm going to do the first one, and then you can go on from there and have a go on your own. So in this first sequence, I've only got 7, 14, 28 and 42. Now I know that 7 and 14 are both in the 7 times table. And I can also see, I know that 7 is double 14. So I know that it is in the 7 times table, this sequence. And I know that they are only counting on by 1 7 each time. Okay, so I could start at 0, 7, 14, and then I would have 3 times 7, which would be 21. And then I've got 4 times 7, which is 28. 5 times 7, which is 35. 6 times 7, 42. And then I've got 7 times 7, which is 49. Okay, so I took those two numbers, had a little think about what I know about them already, and it looks as if I've been able to fill in my sequence, and it is a sequence of the 7 times tables. So see if you can have a go with the others, and we'll come back and have a go together. So I hope you got on with that okay. It wasn't too difficult. It's just to get you back in the motion of using number lines and recognising patterns within them. So here we had the 7 times table as our pattern. Now with this one, we've got 4, 16, 24 and 28 as the missing numbers because we are using the 4 times table. Now I noticed that it would be a number between 0 and 8 here, and I knew that 8 and 12 were in the 4 times table, but there was also 4 between them. Okay, so I used that to help me fill in the missing places. And then here it started at 8, which was a bit unusual. So I noticed that 12 was the next in my number line, so it would have needed to be a number between 8 and 12, and I noticed that the other numbers had 2 in between them, so 16, 17, 18, so I realised that it was the 2 times table. And then lastly, it started at 12, which I thought was a bit strange. However, I then counted on and saw it was 15, and I know that 3 times 5 is 15, so for my next guess, I went for 18, and it just went upwards and ascended, and it was using the 3 times table. Okay, so I hope you got on okay with those ones. Now today we are going to be looking at finding tenths on a number line. So we're going to be looking at recognising tenths on a number line, and also we're going to have a look just briefly at how we might use those to measure things, measure things with tenths on a ruler. So how many equal parts is this number line split into? So we've got 0 here, and then we've got our whole number 1 here. So we know that it is going to be parts that are smaller, numbers that are smaller than 1 here. So let's have a little jump and we can see how many it takes us to get to 1. So we can see what the increments are, so what these little spaces are in amounts. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are 10 equal parts. I'm just going to write 10 there. So each of these is equal to 1/10. Okay? So if we know this is equal to 1/10, we could write that as a decimal here. Now, if we've got 0.1 here, because that marks 1/10, where would 0.5 go? Well, we know that 5 is half of 10. So 0.5 would go somewhere in the middle because we're halfway to our whole number. So 1, 2, 3, 4, 5. So we have got 0.5. And as you may have learnt from yesterday, 0.5 is equal to 5/10, just right over here, and 5/10 is also equivalent to a half. So 0.5 is equivalent to a half as well. Okay. Now, is there an object in our classroom that has a number line like this? You may also have one of these at home. Have a little guess and see what you think it may be. If you guessed ruler, then you would be correct, because in 1 centimetre, we have got millimetres, haven't we? And in 1 centimetre, there are 10 millimetres. We also know that 5 millimetres is half a centimetre. So 0.5 again is equivalent, is equal to a half. So on this number line, we have got, again, the numbers are going up. However, they are going up in a slightly different manner. They're ascending a little bit differently. So when we say ascending, that means we're going up the number line, we're counting upwards. And if we were to go backwards down the number line, we would be descending. So pause the video and see if you notice anything different about the way the numbers go up here. If you noticed that they are going up 2/10 each time, then you would be right. Because here you can see we've got 4 is a whole number, 4.2, 4.4, and then here we've got 5 as a whole number and 5.2. So we know that it is jumping up in 2s. So each time we jump up, we're jumping up 2/10. So we're adding 2/10 onto our number. So each of these parts, we're adding on 2/10 instead of 1. So when we have number lines and when we're ascending, we can ascend in many different ways. So just like with our calculation starter, when we do number sequences, we can jump up in many different ways. Number lines are the same. So I want you to pause the video here and see if you can match the numbers to the correct places on the number line. Have a go at doing this with a pencil and a piece of paper, and I will fill it in and I will see you when you get back. Okay, so here is my number line. I hope you got something similar, although I have made a mistake and I'm hoping that you'll be able to spot the mistake. So have a look at it first. See if you notice anything that maybe isn't quite right. So I've got 4.2, because remember, we're counting up with 2/10 each time. We're going up 2/10 each time. 4.4, 4.5, 4.8. This isn't quite right, is it? Because I should be counting up in 2s, not 1/10. I'm not adding 1/10, but I'm adding 2/10. So I need to swap this for 4.6, 4.8 and 5. Now, I put 5 here. I'm not putting 5.9 because remember, we are counting up in 2s and 10/10 makes 1 whole. So because I've got 4.8, I've added another 2/10, which takes me up to 1 whole. So I now have 5, okay? So slowly my tenths are increasing until I can finally change my whole number from a 4 to a 5. So then I've got 5.2, 5.4, 5.7. Oh, 5.7. Again, that's not quite right because I've stopped counting up in 2s and I've started counting up in 1s. I need to remember to keep it the same increment, keep it the same amount each time. 5.8, 6, because remember, I've got my whole number now and I've added 2, so that 8 has now made my 5 change to a 6 because my tenths have become a whole number. 6.2 and 6.4. So I hope you all got on okay with that one and didn't find it too tricky. If you ever think something doesn't look quite right, remember what you're counting up in, okay? So remember how many tenths you're adding, okay? Because that shouldn't change as you go up the number line. So here we have got a ruler. So remember how we said we noticed that on a ruler, a centimetre has 10 millimetres and it counts up in those increments each time. So let's have a look here and try and measure this piece of ribbon. So the ruler goes up in jumps of 0.1 metres. So here we've got our whole number and we have got our 0 here and we know that it counts up in 0.1. So we've got 0.1. If you'd like to have a go at finding out how long the ribbon is meters long without my help, pause the video. If you want to carry on and do it with me, that's absolutely fine. So we've got 0.1 here, which means we would have 0.2, 0.3. I'm just going to pause the video whilst I write the others in. Okay, so it's going up 0.1 every time. So it's going up a tenth each time. So I need to figure out how long this ribbon is. But one thing I've noticed is that, strangely, they haven't started on 0. So it starts on 0.1 and it ends on 0.9. Now, you might think that means that the ribbon is 0.9 of a metre. However, we've forgotten about this bit here. And here we've already jumped up 0.1. So we've actually said it's 0.1 longer than it actually is. Okay? So we need to remember if the ribbon isn't on 0, or if whatever you're measuring isn't on 0, you need to act as if where it is measuring from is 0. Okay? Or one thing you could do is, because you know it goes up to 0.9, you could take away the 0.1 that has been measured. And that would leave you with, I haven't left myself much room there, but that would leave you with 0.8. And let's jump just to make sure. So we're jumping from the start of the ribbon here, 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8. So I know that it's 0.8 meters long. Because remember, the ribbon doesn't start from 0, so I can't include this 0.1 here. It starts from here, so it's 0.8. So now you've got a worksheet which has got a few activities on. So there are a few basic ones where you need to fill in the number line, and then there's a few more complicated ones where you need to decide what numbers should go on a number line, and also you need to measure something as well. So remember all of these tricks that I've taught you here. Hope you get on with that okay, and I will see you tomorrow. Take care, bye.